Hello all, welcome to the first episode of Fluid Shots. So today we'll be discussing about why do birds fly in a V. So let's begin our discussion. So what is this V formation? I think you all might have seen these kind of pictures, right? These are very common pictures. Uh, Usually, if you can gaze, if you do gaze in the sky, you will see these kind of pictures, these kind of orientations or formations with which the birds fly, especially the migratory birds, who have to travel a longer distance as compared to the other local birds. But basically, these are the orientations that we see with those kind of birds flying, not any other alphabets like S or D or W, right? So why is that? Let's try to figure this out, right? Okay, so scientists, after a lot of research and a lot of studies in this field, they come up with two reasons which they seem reasonable and convincing enough. So the first one is the that it conserves their energy, right? So it's very less tiring as well as less effort is used by the birds. Okay, that is something I agree, but we need to dive a little deeper into it to understand that how this thing is happening with the proper science behind it. And the second thing is effective and efficient communication with their community. So it helps in keeping a track of everyone in the group. So for example, if this is the whole group, so it's very easy to have proper communication, whether they all are flying properly or any other communication. I don't know what they talk or how they talk, definitely, but yeah, they will have their own ways of communicating, not like us humans. But yeah, the it helps in keeping a track of it that everyone is there in the group. They are all flying. But what we are mostly interested is to understand this very the first point, right? So how it helps in you know conserving their energy, right? And can this be used in any other aspects also? Because nature is the best example of uh, engineering miracle, and we as engineers, what we try to do, we as engineers, we as scientists, we as people from other departments which concerns the development and not only the technological development, also understanding the nature closely. What we try to do, we try to imitate the nature, right? We try to imitate from the nature. So can we imitate this property and make something which will be helpful for the mankind? So let's see. So as I move on to the next thing, so how is this V formation effective? Of course, the first point which I was telling you, we'll be discussing about this point. So it is less tiring as less effort is used, so it conserves their energy. So the first thing which backs this thing is the boundary layer concept. So we know that when a flowing fluid, right, it comes in contact with a solid boundary, so it tends to form a layer like this, right? So initially you will have this layer which is very close to the wall of a solid boundary to be behaving just like that of the solid boundary because of no slip boundary condition, and slowly because of the presence of viscosity and all, so you'll see a boundary layer being formed, and here and gradually the velocity from the relative velocity from 0 to v infinity, it will increase in the vertical direction, right? And what happens to shear stress will keep on decreasing. So initially the shear stress or the resistance will be very high at this point, and gradually along the flow of the body, it will decrease. So if you see in this picture, the front one, this is the commander in chief. Now this guy has to be strong enough to to cross this fluid envelope. So it's like a fluid envelope, and you need to be as effective like an arrow, right? It's like an arrow shape only, right? So you need to cross past this effective fluid envelope. So this guy has to be strong enough to resist the shear stresses and the forces that are formed over here. And gradually, these forces will be very much less effective as we move along this line. And these two bodies over here, they'll be having very less force to resist. So it won't be a problem for you. So strategically, these guys should position themselves. So basically, the strong guys will be here in this front row positions, and they can they can take turns to change their positions in case of long flights, right? So they will take turns once they are tired, and they will keep on shifting position, and that's how this whole group they'll move. So the first thing we understood is the boundary layer concept. The second thing, which is another interesting thing, is the vortices formation. So basically, if you see, this is an example of the wings of an airplane. So if you can see, this tail vortices or the tip vortices are formed, right? So if this is the rear view of the plane, so I can see this trailing tip vortices are formed, right? And because of this formation, this particular zone, which includes the wingspan and the body of the plane, is having this downward or the negative flight, negative lift. That's what it's my mistake. Negative lift, right? And the adjoining zone here on both the sides will have what? Will have a positive lift. So now just imagine if you replace this flight with a bird, same thing, right? So this flight has if I replace this zone or this flight with bird, same thing will happen. Same dynamics of same this trailing tip vortex. What I am seeing, I can see this. As you can see, this tip vortices will be there, and this red zone, as I can see here, so this will be the downwash or the negative lift region. So if anything, any object falls in this particular region, what will happen? It will be very difficult for this object to match its height, and also more effort will be required to fly along this path, right? But if something is flying along this region, if an object is here, so with very less effort, and mostly because of gliding, because it's already providing a positive, a positive lift. So it's like basically you're gliding through this region. So what we need to do is we need to understand the effectiveness of this region, and we need to explore more of this region. So better than us, I guess the birds, they have explored it already, because they have been doing this for centuries. So they have done this effectively, and it's time for humans to understand that and put it into use. So that's another reason. So the first reason is the boundary layer concept, followed by the second reason, which is the vortices, the trailing tip vortices, and this zone of downwash and the upwash, right? So what is happening around the globe? So are we, effective enough to mimic the motion of or the movement or the formation of the birds? Yes, we are. I think if, this picture is a very common picture for us, especially during the parades and all the Republic Day parades and all. We have seen these kind of pictures, right, where the jet fighters, they'll be flying in this V shape. So why is this? Same reason which we have discussed before, right? Less consumption of energy. That means you're saving more fuel. That means it is becoming efficient, right? Airbus, as you all know, it's one of the key players in this field of aeronautics, right? Especially the passenger vehicles. So Airbus is one big name. They're planning to fly passenger aircrafts in fleets. These kind of orientations, right? So passenger planes could fly in V-shaped flocks like migrating birds to cut down on the shameful emissions. Because everyone now is focused on this emission thing, because that has become a very big issue nowadays, right? Because of all the global warming and other norms being very stricter. So this has been a very key concern, right? So they are also planning. This is a plan in progress, but uh, this will help cut down, I think, the fuel cost, also maybe the airline ticket costs by some margin. But what will be the concern is convincing the passengers, especially that hey, you will be flying along other passengers also, because that might scare a few people, because a lot of accidents might turn up. So we need to see how this thing works effectively on real life scenarios. This is just a theoretical thing right now on paper. So let's see if this can come up and we can fly on a reduced, fare. The other thing is the Air France KLM, along with TU Delft University, they have come up with a very interesting design, right? Usually, what happens, the passenger seats are not designed in the wings, but here the passenger seats are designed in the wings. So this gives you more flow path area, and this is exactly like you take the surface, you do some sort of material improvisation, and you come up with this. So moving on, so these are the basic reasons. So I think we understood that why this V formation of birds is there, and why we used to draw in our childhood days, when we used to draw a very cliche scenario like this. I guess if I am good at it, I'll try. I'll give a shot. Okay, we used to draw this kind of scenarios, right? So you'll have a mountain, you'll have some river, you'll have a house. See, I'm very poor. Drawing here, drawing on paper is easy. Drawing with this, it'll take me little time. These and here you'll draw birds like this, right? So at least I used to draw in a V formation. I don't know why, even if not knowing the reason, but now I at least I figured out the reason, I guess, and I guess you guys also figured out why I used to draw in V formation and how fluid mechanics, especially here, plays a very crucial and important role in helping us understand that this V formation, which the birds have been adapting since ages, can be used effectively in our flight dynamics and that will help us to travel faster, to travel safe, and with very less cost. So, thank you all for being so patient and listening to us. So, do subscribe us for more updates. Thank you.